All right, welcome to the last lesson of trimester 1. You did it, you made it, you're almost finished. This lesson is actually pretty tricky. It's all word problems dealing with inequalities today. So let's take a look at our aim. Our aim says, I can model and solve real-life situations using inequalities. So we're going to talk about some word problems today. I know, they're your favorite. Don't get too freaked out or excited. Let's take a look and read. Just as we can solve many real-world problems involving linear equations, which is what we've been doing in Unit 2, there are plenty of situations where an inequality is called for instead. In this lesson, In this lesson, we'll practice setting up and solving inequalities based on real-world scenarios. So exercise 1 says, a school is taking a field trip with 195 students and 10 adults. Each bus can hold at most 40 students. This should say people. So on your paper, change this word to people. There's a typo. Sorry. So each bus can hold at most 40 people. So the bus can't hold more than 40 people, okay? We need to determine the smallest number of buses needed for the trip. So A says, using a guess and check method, determine the minimum number of buses needed. Show evidence of your thinking. So guess and check means that, well, we're going to guess a certain amount of buses and see if it works. So let's try 4 buses for our first one. Keeping in mind, what's the total amount of people we have? We have 195 students and 10 adults. So how many people is that? 195 plus 10. So we need to fit 205 people on these buses. So like imagine you're taking a field trip, right? So let's try 4 buses and see if that works. So let's try 4. Well, 4 buses can hold how many people? Where is it? 40 people at most. So 4 buses times 40 people, because 40 people can go on there per bus, is going to be how many people? 160. So that means 4 buses can hold 160. Is that going to be enough? No. 160 is less than 205. So 4 buses is not going to work. We don't have enough buses. We're going to have 45 people sitting out waiting for a bus. How about we try 5 buses? Okay, so we'll have 5 buses now times 40 people. That's going to give us 200 seats. Is that enough though? Nope. 200 is still less than 205. We're going to have 5 people sitting out not being able to go to the field trip. So now let's try 6 buses. If we keep going up, notice how we're getting bigger and bigger each time. So if we try 6 buses, we're going to have 6 buses times 40 people. That's going to give us 240 seats. Is that going to be enough? Yes, because 240 is greater than 205. So 6 buses will work. Now, this would take a long time having to guess. If you're a business manager of a school and you're trying to order buses, you don't have time to sit and guess how many buses you need. You need to do some math to try and figure out how many buses you have to take. If money's involved and you're actually ordering these things. So let's make an equation. B says, let n be the number of buses taken on the trip. Write and solve an inequality that models this problem. So we're now going to use a variable to help us solve. So what math have we been doing each time? We've done 4 times 40 each time, 5 times 40, 6 times 40. So if n is the number of buses, our equation is going to look something like this. 40 times n, because that's what we did each time, 40 times 4, 40 times 5, the number has to be bigger than 250. So I'm going to use an inequality, because 160 didn't work, 200 didn't work, but all of a sudden when I got, 205. All of a sudden when I got a number bigger than 205, that was my answer. Okay? So now we're going to solve. I'm going to write this a little nicer. 40n is greater than or equal to 205. Divide both sides by 40. The 40s cancel out and I get n is greater than or equal to, and I'm going to get a decimal, 5.125. Now we have to take this number and we have to round up. Why are we rounding up here instead of down? Well, because we can't have 0.125 buses. You can't, have like a section of a bus and it still work. So we can't order 5 buses because look what happens when we're 5. We're missing 5 people. But if we order 6 buses, we need 6 buses. Yeah, we'll have leftover seats. We're going to have like 35 leftover seats, but we'll have enough for everyone to get on. Okay? So this is one example of a real-world situation that uses inequalities. Okay? Let's take a look at a couple others. Exercise 2. It's important that you're able to deal with phrases at least and at most. So there's something really important with this. I'm going to move this down a little bit so you can write on your paper. When you have the phrase at most, you have to use the less than or equal to sign. If you have the phrase at least, you need to use a greater than or equal to sign. I know that's kind of weird because you think the word most and you think that means big, and you think the word least and it means small, but it's really the opposite. So at most is a less than or equal to sign, and at least is a greater than or equal to sign. You have to memorize this fact right here. And that's going to come into play in these 2 problems. So letter A says that translate each of the following phrases into inequality. Do not solve. So we're just going to translate. When 3 times a number n is increased by 12, the result is at least 32. So I'm going to first start by translating 3 times a number n. How do I do 3 times a number n? 3n. Then I'm going to translate the next section. Is increased by 12. So increased by, that means plus 12. The next part says the result is at least, well, I'm going to go up to here and notice at least requires a greater than or equal to sign. Okay, a greater than or equal to sign. Wait, let me use a different color for that so you can see it a little bit better. Okay, sorry about that. I just want you to really understand what part goes with what. So let's use purple. And at least is going to give me that greater than or equal to sign. And then the last part is that 32. It's at least 32. So that's my translation. 3 times a number is increased by 12. It's going to be at least 32. So at least is saying it's got to be bigger than 32. It's got to be at least 32. So a number bigger than 32 is okay, but it's got to be at least 32. Let's try the next one. B. The sum of 2 consecutive even integers, n and n plus 2, is at most 8. So I'm thinking sum, so I'm thinking adding here, and I'm going to be adding what? N, and I'm going to be adding n plus 2. So I'm going to start my problem off by saying n plus 2, there's my sum, and then translating the inequality. Oh, my laptop locked up for a second, that was weird. The inequality is at most, well, that's a less than or equal to sign, just like it says here. And the 8, it's at most 8. All right, so 2 things, at most, at least, have very different translations. You're not using the equal sign anymore, you're using these inequality signs. All right, now let's try creating one and solving at the same time. So exercise 3 says, find all numbers for which 5 less than half the number is at least 7. Set up an inequality. Okay, so let's translate this. Let me get my different colors. Okay, so the first part of this says 5 less than. So 5 less than is like saying a minus 5. So I'm going to have a minus 5. Half the number, well, there's where my variable comes into play because, that's like an n. So it's half of n, and when I have the phrase less than, I have to switch these 2 things, so the 1/2 n goes in front. Then I'm going to translate the next part. Is at least, remember I'm going to go back to my thing, at least is a greater than or equal to sign. Make that a little bit nicer. Okay, and the last part is the number 7. Okay. So there's my equation. I'm sorry, my inequality. Now I have to solve this. So let's solve. The first thing I have to do here, I'm going to try to get n by itself, so I'm going to add 5 to both sides. The 5's cancel out, and I have 1/2 n, is greater than or equal to 7 plus 5 is 12. To get rid of a fraction like I've taught you, you multiply both sides by the denominator, and you're left with this 1n, but the 1's invisible, and 12 times 2 is 24. So any number greater than 24 would be an answer to this. 24 would work, 25 would work, 26, 100, 1,000, anything bigger than 24 would work here. Okay? All right, let's take a look at another one. Exercise 4, find all numbers such that twice the sum of the number and 8 is at most 4. Solve this problem by setting inequality. So let's again start translating. Let's start here. Twice the sum. So remember, twice the sum always looks something like this. Something plus something else. So I know when I have this, it's going to be 2 plus something, twice the sum. What is the thing that goes inside? Right here. The number, so that's n, and what else? 8. Okay, twice the sum of the number and 8. And at most, if I go back and look, what kind of symbol is at most? It's this less than or equal to sign. So that's what I'm going to translate here, is at most. Oh, I don't know why I wrote the 8. Is at most 8. Why did I keep saying 8? I meant 4. That says 4. Sorry. 4. Alright, notice my colors match up with my translations. Okay? Now we have to solve. What's the first step in solving a problem like this? We can distribute, or we can divide both sides by 2. I don't care which way we do, but let's do distribution because distributing is fun. 2 times n is 2n, 2 times 8 is 16. Carry down the less than 4. Now we subtract 16 from both sides and get 2n is less than or equal to 4 minus 16 is negative 12. Divide both sides by 2, and I get n is less than or equal to negative 6. All right. Again, if you have questions or don't understand, mark it on your paper. Remember to ask me in class or send me an email. That's what I'm here for. Okay? All right, the very last part of this packet, of this lesson, is a very large word problem. Look at how much reading is involved here. So we're going to take this slowly and think about this problem carefully, one step at a time. So here's a real-world situation that a lot of people that manage sports and stadiums have to think about when they're trying to make money. So this is a real problem that a lot of people have to think about. So let's read. A stadium is steadily filling up with people. It holds at most 2,500 people. Of the 2,500 seats, 350 are reserved for special guests. When the doors open, people fill the seats at a rate of 10 seats per minute. That means that every minute, 10 seats are filled. Okay? So let's look at A. If M represents the number of minutes that has gone by, I'm going to write that down somewhere. So M equals minutes. Just so I'm clear. My pen does this thing where when I write, the letters connect to each other, and I don't know if it's my pen going bad or my board or what, but it's irritating. So I'm sorry, I have to rewrite that all the time. So M is minutes. So if M represents the number of minutes that have gone by, fill out the following chart for how many seats have either been taken or reserved. So let's look at after 1 minute, how many seats are filled? Well, let's look at our rate. 10 seats fill up per minute. So after 1 minute, we have times 10, so 10 seats get filled. Because 1 minute's gone by, 10 seats are filled, 10 seats per minute. The total is going to be those reserved seats, so 350 plus 10, so the total seats now in the stadium are 360 that are filled. After 5 minutes, what's going to happen? After 5 minutes, I'm going to have, 5 minutes go by, and they fill up at 10 seats per minute, so that'll be 50 seats after 5 minutes. 10 seats per minute, 10 plus 10 plus 10 plus 10 plus 10. Then I've got to do 350 plus 50 to get my total, and there's 400, right? Because I'm adding the reserved to my new one, so I'm adding these two together. After 50 minutes, I'm going to do another multiplication. Now I do 50 times 10. That gives me 500. So I have then 500 plus 350 is going to give me 850. So I've got 850 seats filled up. So I'm filling up my stadium. After 100 minutes, same thing. 100 times 10 is going to give me 1,000. So I'm going to have 1,000 plus 350, and that's going to give me 1,350. So I'm starting to see a pattern here. I'm starting to kind of see that I'm multiplying by 10 each time, then adding 350. Multiply by 10, add 350. So that's what's happening. I'm multiplying by 10. My pen. I multiply by 10, and then I add 350. So this is my pattern I'm seeing. So I'm going to write that over just in case I need it later. Now let's look at B. Write an expression that calculates the number of seats filled and reserved in terms of n. Well, that's where this comes into play. So where is m in my table? Well, m is this number right here that changes every time, because it's a variable, right? The 1, the 5, the 50, and the 100, those are what changed. So that's my m. Then what did I do to the m? What was the first thing I did? Look up here. The first thing I do is what? Multiply by 10. So 10 times m. What's the second thing I did? I added 350. So there's my expression for how I figured out this total. I did 350 plus whatever I multiplied by 10 here. Okay? That's probably the hardest part of thinking about that relationship, right? Letter C, write an inequality that shows times in minutes before the stadium is overfilled. So we're going to go back up to this idea that, here, look, this stadium holds at most 2,500 people. So how would I translate at most? Well, I use that less than or equal to sign, 2,500. And what goes over here? My new expression, 10m plus 350. If this ever goes above 2,500, my stadium will be overfilled, right? If I go, let my stadium sit for like 300 minutes, there might be more people than 2,500 and it would fill up too fast. So now we're going to answer some questions about our equation that we just made. It says, at the rate that people are entering, will any more people be able to find a seat after 4 hours? Well, now this becomes a little tricky because what unit have we been working with so far? We've only been working with minutes. So now we have to figure out, okay, 4 hours, let me use a different color. We have to think about how many minutes are in an hour. So I have 4 hours, and how many minutes will that be? Well, how many minutes are an hour? 60, right? So it's like saying 60 plus 60. In fact, let me do this a little easier. 60 minutes plus 60 minutes plus 60 minutes plus 60 minutes. And that would give me my minutes. I'm converting 4 hours into minutes. So 4 hours is really 240 minutes. So at 240 minutes, are people going to be able to have enough time? Oh, I missed a step here. Oh, look what I forgot to do, because I was like, wait, how am I going to figure this out? Look what I forgot. What did I forget to do right here? I didn't solve this inequality. So I'm having a hard time with D because I forgot to solve. So let's solve this. This is my bad. I'm so sorry. Let's go back up here and solve this. 10m plus 350 is less than or equal to 2,500. My bad. So we subtract 350 on both sides. I get 10m is less than or equal to 2,500 minus 350 is 2,150. Divide both sides by 10, and I get m has to be less than or equal to 215. So that means, my meaning is that at 215 minutes, the stadium is full. Okay? That's what that means. So now if I go to D and look at this, 240 minutes, what does that mean? Will anybody be able to find a seat after 240 minutes? No. Because 240 is bigger than 215. By 215 minutes, it's full already. So anyone that comes in at 240 is not going to be able to find a seat. There'll be no seats left. Okay? Let's move on to E. To cover the cost of the stadium labor and other overhead costs, stadium organizers must raise at least $39,000 from ticket sales. If they sell tickets at $25 each, will they have covered the cost if 1,250 tickets are sold? Okay, well, that means that if I sell 1,250 tickets and they each cost $25, is that going to be enough? Oops. Is that going to equal 3,900? More than that, not equal, but, oh my gosh, my pen. Not equal, but it has to be at least 39,000. That's where this word at least comes from. So we need a greater than 39,000. So 1,250 times 25 is 31,250. Is that greater than 39,000? No. So not enough. Okay, now letter F, I don't have it on here, I don't believe. I think I forgot to put it on here. So letter F, I want you to try F on your own, and then I want you to show me in class. So show me in class what you get for letter F on your notes. My pen is so messed up, so I'm going to try and get that fixed because it's writing really weird. But I want you to show me F in class and let me know what you get. All right? This is the end of trimester 1's lessons. Good luck. I know this lesson was a little harder than some of the others, and please, please, please ask me for help on your fluency if you need it. All right? I'll see you guys in trimester 2.